Bandwidth is another fundamental antenna parameter. Bandwidth describes the range frequencies over which the antenna can properly radiate or receive energy. Often the desired bandwidth is one of the determined parameters used to decide upon the antenna. For instance, many antenna types have very narrow bandwidth and cannot be used for wideband operation.
Bandwidth is typically quoted in terms of VSWR. For instance, an antenna may be described as operating 100 to 400 MHz with a VSWR 1.5. This statement implies that the reflection coefficient is less than zero point 0.2 across the quoted frequency range. Hence, of the power delivered to the antenna, only 4% of the power is reflected back to the transmitter. Note that the above does not imply that 96% of the power delivered to the antenna is transmitted in the form of EM radiation. Losses must still be taken into account.
Antenna gain. The term antenna gain describes how much power is transmitted in the direction of peak radiation to that of an isotropic source. Antenna gain is more commonly quoted than directivity in an antenna's specification sheet because it takes into account the actual losses that occur. What is gain of antenna? Antenna gain is the ability of the antenna to radiate more or less in any direction. Compared to a theoretical antenna, if an antenna could be made as a perfect sphere, it would radiate equally in all directions. Such an antenna is theoretically called an isotropic antenna and does not in fact exist.
Antenna impedance relates the voltage to the current at the input to the antenna. This is extremely important as we will see. Let's say an antenna has an impedance of 50 ohms. This means that if sinusoidal voltage is applied at the antenna terminals with an amplitude of 1 volt, then the current will have an amplitude on 1 over 50 is equal to 0.02 ohms. Since the impedance is a real number, the voltage is in phase with the current.
BSWR stand for voltage standing wave ratio. We use that an antenna's impedance is important for minimizing impedance mismatch loss. A poorly mismatched antenna will not radiate power. This can be somewhat alleviated via impedance matching, although this doesn't always work over a sufficient bandwidth. A common measure to how well match the antenna is to the transmission line or receiver is known as the VSWR or voltage standing wave ratio. It's a real number that always greater than or equal to 1. A VSWR of 1 indicates no mismatch loss. The antenna is perfectly matched to the TX line. Higher value of voltage standing wave ratio indicate more mismatch loss.
Let's proceed to the impedance. Impedance. Impedances is the resistance to the flow of electrical current. The higher it is, the higher the resistance to the flow. The lower it is, the lower the resistance to the flow.
Compatibility between high Z and low Z. Low Z, it means low impedance, and high Z, it means high impedance. A low Z output would cause problems if plugged in a high Z input. Only a limited amount of electricity could flow into the input even though there is a lot more electricity in the output.
Every machine on the internet is connected by a cable. Usually there are the other ways to connect computers, but cables are the most common and all connections have and use bandwidth in the same way. This cable has a capacity, it can carry a certain amount of information, sort of like a water pipe carries water. At either end of this cable, there is some sort of computer which can send or receive data at a certain speed.
In computer networks, bandwidth is often used as a synonym for data transfer rate, the amount of data that can be carried from one point to another in a given time period or usually a second.
What is bandwidth? It is the rate of speed information travel across phone or cable lines. How it's used today. All information access throughout the world uses bandwidth, whether through the phone or computer. Bandwidth has always been used in some form to transfer information. It's had been around longer than people think.
How does a person steal bandwidth? It is only possible to steal bandwidth through wireless connection. She didn't want to go any further to the subject. She encouraged online research simply for legal issues. Are there any solution to the bandwidth dip? The best solution is to place software firewalls and hardware firewalls on all protected documents.
What does the future bandwidth look like? Bandwidth will continue to be used throughout the information age. If anything, there will probably be discoveries on ways for it to run faster and be even more efficient. Will there be any upgrades to replace the need for bandwidth in the future? Upgrades and differently possibles, there always be improvements made to bandwidth, but replacing it doesn't seem to be happening anytime soon. The technology world will always find new discoveries and ways to make things better, so who knows what may be possible.